welcome back. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, as part of a data mining video lectures series. In this lecture, we are going to discuss one method in data pre-processing that is called as a data cleaning. So in this, we are going to discuss methods used to fill the missing values. There are 6 methods. We are going to discuss those 6 methods, how we can use those methods to fill the missing values. So we just go back to the definition of data cleaning. So data cleaning routine, it works to clean the data by filling in the missing values, smoothing noisy data, identifying or removing outliers, and resolving the inconsistencies. The previous lecture, we have already discussed the different types of methods used in data pre-processing. So data cleaning is one type. In this, we are going to discuss how to fill the missing values. Even if a user believes the data are dirty and they are unlikely to trust the result of any data mining that has been applied. So it is very important to deal with the missing data. So there are 6 methods in this to handle this missing values. That is the first method, ignoring the tuples. That is another second method, fill in the missing values manually filling the missing values. The third method is, the third one is a global constant to fill in the missing values. And the fourth method, we use measures called as a central tendency measures like a mean, median to fill in the missing values. And for fifth method, we use the attribute mean or median for samples belonging to the same class. And the sixth one is, we use the most probable value to fill in the missing values. So in this lecture, we are going to discuss in detail about all these 6 methods. So let us see one by one. The first method, the previous lecture we already discussed what are the possible reasons of having the missing data. So the first method that is we use in data cleaning is ignore the tuple. So you can see at the previous lecture we already discussed about what is a data set and what are all these, like the columns and what we call all these rows. So here you can see in this data set, and the highlighted with the red rectangular colors like this, NaN, not a number, and this is another, and this is, and these are the information. Like suppose if you take this record 4 and the address information is missing, and if you take the 5th record and the city information is missing, and if you take the 4th record again and the marks information is missing. So if any data is missing, mostly we would replace that missing data with a constant called as a not a number. So our objective is to first to find out the percentage of missing values in our data set, because depends on the percentage of missing values. So we are going to decide which method is more appropriate to clean this or to handle this missing data. So we have to check the total count, the number of missing values. Like a row could have a missing values. Like suppose in this case you can see the 4th record has 2 missing values. Like even some few other records may have more number of missing values. And like whether the rows could have a missing values, and also the columns. These are called as features, attributes. these columns also would have a missing values. So sometimes a row may have a more number of missing values, sometimes a columns also may have a missing values. So the first approach is ignoring the tuple. That is, ignoring the tuple is simply deleting. So suppose in this data set, the record 4 has 2 missing values, so that we could delete the entire record from this data set before we go for further analysis. And similarly, fifth record also have a missing value, so that we can remove this fifth record also. And similarly, like suppose if there are some like the missing values under the column city, like these are all, let us say these are all the missing values, okay, or let us say like 80% of the values under this column city are missed. So in that case, you can simply remove this entire column, because 80% is most significant, so better to remove this entire column. So like that, we will decide what need to be done. So whether we could use, like if you want to ignore the tuples, so and you have to check before whether the records have a more number of missing values for the columns, if any specific column has more number of missing values. So accordingly, we will proceed. So suppose if you want to delete a record, let us just imagine, let us say you have some 1000 records in your data set, and let's just assume that if each record have the missing value, and if you would follow this approach called as ignoring the tuples, so then we would delete all the records, because each record has a missing value, okay, either the one missing value or two missing value, at minimum one missing value. If you follow this approach, then we would end up with a empty data, okay, because you would delete all the records due to the missing values. So this is not always recommendable. And next, second approach, the second method to address this data missing values is filling the missing values manually. So manual filling means, like suppose if your data set size is very small, and it would be recommendable, and even the data set size is small, and approximation by the human beings is not more accurate, and then also it would not be recommendable to fill the missing values manually. Next, another method that is very, very important one is use a measure of central tendency for the attributes, for example mean, median, to fill the missing values. So here you can see how the data distribution, if the data distribution is a symmetric like this, then we could say like data is following the normal distribution, and the data here you can see the skewed data, okay, whether it is a left skewed or the right skewed, you can see. But whereas in the symmetric data, you can see the right half and the left half both are in a symmetric almost. Okay, so depends on the data distribution, we will follow like whether, so before we apply, what I mean to say, before we apply an either to fill the missing values by using measures of central tendency, so we have to understand what the data distribution looks like. So if it is on a symmetric, so then it would be recommendable to use, or if it is a skewed data, so whether it is recommendable or not, we have to check. And for example, if your data follows the normal distribution, you can see the data distribution like a bell curve. It is almost it looks like a bell-shaped curve. And the data distribution also you can see like the most of the data values, then the 15% and then 10%, similarly to the left also. So most of natural data would follow the distribution like this. So then we can say it's a normal distribution. So if the data is following the normal distribution, it is always recommendable to use the mean or median to fill the missing data. And second, when the data is interval data like this, in this on the left of this one is interval data, age, and whereas this one is a continuous data. If your data is interval and also the continuous data, and it would also be recommendable to use the measures of central tendency to fill the missing values. For example, I would like to show some simple coding part also, so that what is the effect, right? We cannot just simply follow the approach, right? We cannot directly apply the mean, or we cannot directly apply the median to replace the missing values, that is an imputation. And this is a simple data set, that is a Titanic data set, which I obtained from the internet. In this data set, we can see this data set, and this data set has the attributes like a passenger ID, survived, P class, name, sex, age, and the siblings, like all these attributes it has. And as I said, we have to check the percentage of missing values in a data set. So that is a very, very important one before we proceed to apply any imputation methods. So here you can see, if you apply this, like if you want to find out the null values, that is not missing information in this data set. So here you can see this age, which is highlighted in the blue color, 19.86%. It's a significantly higher in number. So under the age column has this 19.86% of missing values. And similarly, some other like a cabin and embarked is very less missing values, whereas a cabin has significantly higher, like 77.10, that is the highest. So in this case, we could not, like whatever the insights we derived, whatever the analysis or predictions could be done based on this, it would not be more useful or accurate. So that completely highly deviate from the real world data. So then I would like to apply this. So let me just quickly run this simple code, and just divide this data set into the train and the test, and I'm going to apply this the imputation based on the mean and median to this age, that is for this x underscore train. So here you can see this is the new column which is added, and based on the mean, that is age underscore mean. Similarly, we could also apply the median also. So you can also see that the new column here, age underscore median. So now we are going to plot this to clearly understand the imputation. Because we fill the missing values, that is under the age column, with the mean and median, and whether the imputed values are very close to the real values or not. So let us try to understand from this plot. Let me run it again. So here you can see, and this is the graph, okay, so which is plotted against the density and age underscore median, age underscore mean. 3 lines you can see with the different colors. So red color is the age, the real values in the data set. The green color is the imputation after applying the imputation, that is mean, and the data distribution would look like this. And the blue color is the data, it shows the data distribution after imputation, that is age underscore median, imputation based on the median, imputation based on the mean. So because you can see some deviation from the real world data, that is a red line shows the real distribution of the data. After imputation, the data, you can see there is a deviation from the real world data. Here you can see, so because 19%, what here this is the 19.86%, that is a significantly higher. So due to that, so most of the data, imputed data, tends to cluster among the central tendency, that is mean and median. So we have to apply this any imputation method after doing some kind of analysis. We cannot simply randomly apply any method. Okay, so we have to do some kind of analysis so that it would be more appropriate, so that we impute or we predict the values which are very close to the real world data. Next, another method in data cleaning, that is to fill the missing values, like use attribute mean or median for all samples belonging to the same class as the given tuple. So the samples belonging to the same class, like any data set, mostly the labeled data. This is a class label we use mostly for a classification purpose. So this sample data describes the iris. There are the iris flower. There are the parameters like a sepal length, a sepal width, petal length, and petal width. And these the based on the values and this are categorized, classified as a setosa, versicolor, and virginica. So, and this by using this approach, what we are going to how we are going to impute the missing values is, here we are going to use the attribute mean or median for all samples belonging to the same class. Like suppose, so let us say there is one more sample where this is missing. Let us say this is some 5.6 and this is some 5. Let us say 0, and this one is so 1.9. Let us assume that, and this is missing. Okay, so in this case, so we know that, like suppose this class label is a setosa. So we know that the class label is a setosa. So that in this case, to impute this missing value, we use either mean or a median of all the samples belonging to the setosa class. Okay, so that would be the more appropriate than the randomly or assigning some other the values which belongs to the some other class, like virginica and versicolor. Those classes may have a different value range in terms of, like, that is a sepal length, petal width, petal length, etc. So, and this by using this method, we based on the samples. So like the sample here, if suppose if the class label is missing for this sample also, so we cannot follow this approach. So if you know the class label of that particular sample, and if any other fields the values are missing, so that we identify the similar samples and we use like suppose in this case we collect all the samples belong to the class called as a setosa, and all those records the sepal length need to be, and then we apply this, we calculate the mean or a median, and we fill that the resultant value and to fill this missing value. So this is the another best approach. And the last approach is we using the most probable value to fill in the missing values. So mostly appeared value will be used to fill the missing values. Most of the time we use regression or inference based tools using like a Bayesian formalism or a Bayesian trees to impute the missing values by using the last method. Let us summarize what we discussed in this lecture. So we discussed the 6 methods as part of data cleaning to fill the missing values. So among those methods, 3 to 6 methods bias the data. So the filled in value may not be correct. Okay. In some cases, a missing value may not imply an error in the data. Some cases, most. So although we can try our best to clean the data after it is seized, So good database and a data entry procedure design should help to minimize the number of missing values or errors in the first place. So that like before, like suppose if there is a possibility to get like all the customers, like let us say there are some 30 fields, and all the customers, those 30 fields may not be applicable for all the customers. So in that case, what could be entered under that attribute? Okay, so that is the way we could minimize. So at the data entry level of this number of missing values or errors. So thank you, and next lecture we are going to discuss about the noisy data.